Hello?
Hello?
Hey, what's up?
Good. What's up, guys?
Not
Good
much.
afternoon.
Good evening. Um, so you said you got another a pretest? Yeah?
Yeah, so it's kind of this. I went to the course today. It was kind of short, and then they gave me the actual test, which is kind of similar to the one we did. We even had like three of the same questions in there.
Okay.
So now I moved on to the next one, which is kind of similar thing, but it's like uh, you want me? I'll share my screen
Sure.
so you can see.
Two-step equations. Okay, cool.
Yeah. So what's the difference? It's now there's just more like instead of there being like one fraction, there's two of them on one side with
Yeah, let me
the
actually
number.
before we start it, let me try and run through like a little bit of examples and then we'll go
Okay.
and do that one. Yeah?
Yeah, that's fine.
Okay. Uh, all right. So one step. Here's one step. One step is either like x minus 7 equals 5. The one step that you do is you do the opposite of the operation. So plus 7,
Yeah.
plus 7, so 12, x equals 12. Another one step is like this. If I have x divided by 13 equals 2. Still one step, you would multiply because the operation is divide. So you multiply to both
Mm-hmm.
sides. That's the opposite. Did I? Just want to make sure I'm recording this. Oh, yeah, cool. So that's also one step. Those would cancel. 2 times 13 is 26. All of that is one step. You can finish it in one single step. Two
Yeah.
steps. Two step equations combine both of those. So maybe we'd have like 2x minus 7 equals, I don't know, 15. So here there are two steps, and there's an order that you have to work with them. Um,
Okay.
the order is whichever is farthest away. That's the way I think of it. Whichever is farthest away from the x, but still on the same side of the equal sign, you deal with
Mm-hmm.
that number first. So we have a 2 that's really close to the x. It's multiplied 2 times x. That's really close. The thing that's farther away is this 7, and we're subtracting 7. So you deal with the farthest away first. So here we would add 7 to both sides. We're doing the opposite still. And then those go
Same
away.
thing.
Yeah, same thing as before, except for now you're copying down, just leaving that alone. And copying
Okay.
it down again. And so 15, 16, 17, 18, 19, 20, 21, 22. And then now you treat it like a one step, like this. You already did the first step, so now you're doing the second step. Here we have 2 times x. So the opposite operation would be, instead of 2
Divide.
times, it would be divide by 2. So we divide by 2 and divide by 2 because we're trying to get the x by itself. So that goes
Yeah.
away, and then we got x equals 11. So it's just a mixture. Some of the
Oh, I
ways
see.
that they can write it, it's kind of weird, but sometimes you could do like 3 x plus 6. This is also a two-step equation, but there's like a couple different things that you could do. Let's say, let's say 27. So on this one, you could, I mean, sometimes this is considered a two-step equation because you can do two things. What I said over here was you deal with the number that's farthest away from the x. In this case, it was 7.
Yeah.
Here, the thing that's farthest away is actually the 3, even though, like, proximity, it's closest. But the parentheses tell me which thing to do first. So, like, the closest one is the 6, and that's because of the parentheses.
So you got to do like the order of operations or whatever, right?
Yeah, and it's
first.
so like if we were just plugging stuff in, we would do the parentheses first because the parentheses make it the closest. But when we're solving more than one step, we're doing the thing that's farther away. So the parentheses make the 6 closest. Farther away would be the 3, so you'd have to divide by 3 because it's 3 times whatever's in these parentheses. So the opposite of times would be divide. So we would divide the 3 off, and you have to do it to both sides. And then you got x plus 3. You could write it in, sorry, not 3. You could write it in parentheses still, but now there's nothing on the outside, so the parentheses don't do anything.
It's gone.
Yeah, so that doesn't matter. And then 27 divided by 3, I think, is 9. And then now it's, again, just a one-step equation. So you do the first step, and then it's the same as before.
So every time it's going to be the furthest one away.
Yeah, if you're solving just a straight two-step equation, you try to figure out what's farthest away, deal with that one first by doing the opposite. In this case, it was 3 that was farthest away because the parentheses made the 6 closer. And it was 3 times this stuff. So the opposite operation was divide. And then afterwards, just to finish this, we do subtraction because it's the opposite sign. And then we got x equals 3. And that would be the answer there. So, I mean, there might be different ways for how two-step equations look, but that's the basic idea. Once you have the equation, you're looking for the thing that's farthest away, deal with that one first, and then after that, it's a one-step equation, and then deal with the next thing. I think when we go through this, we'll just see a couple of situations where the notation will be different, and so it might not be obvious which number is the farthest away. So that's what we'll try and make clear, I think.
So like also with the fractions that they use, right? Because they'll do
right. So like if there's so this is like another way that it could be written. So like x divided by 2 plus let's say 7 equals 9. On this one, still 2 steps. One because we're dividing x, but we're also adding something to x. The one that's farthest away would be, in this case, it would be the 7 because we're directly dividing the x. I'm going to compare that to, so here, closer, whoops, not closer, farthest, this is closer. If I rewrote this, and it's a totally different equation, even though I'm going to use the same numbers, it's completely different just because of the parentheses. So if I had x plus 7 divided by 2 equals 9, simply because of notation, the 2 is now the farthest because the parentheses grouped together the x and the 7. So the closest thing to the x is what grouped it together, which is the parentheses. So, and then this would be the closest. So they switched. No, I spelled that wrong. Doesn't matter.
Yeah, I get it.
So the other thing, one last thing, and then we'll just get into it. This is the same exact thing as x plus 7 without parentheses, as long as this division bar goes all the way underneath the x and the 7 equals 9.
Okay.
The division bar kind of acts like parentheses anyway. So this is
All
like the
right.
more explicit way to write it, but even if there are no parentheses, like this, it means the same thing as that. So
All
that's
right.
just something to be aware of. If the division bar like expands
All the way
from the
across.
variable and the number, then it's the exact same thing as if parentheses are there.
Okay, I'm gonna write this down. Cool.
All right, I'm gonna stop sharing and then we can.
Go check it out. Okay.
Yeah. And if ever like there's something where like you tried it and they gave you a test and you want to go back to something, let me know and we can like make up stuff and go on from there or like search.
Yeah, because after I pass them, also like I can go back and look at them.
Oh, okay, cool.
So I think.
So yeah, if you want to like, oh, I, answered this one, I didn't get it, but we can go back over that. That sounds good. All right. The total cost of Anha's trip to the dentist was $628.35. She paid a flat fee of $89.95, which included the checkup and cleaning, and then had 4 cavities filled, each of which cost the same amount, which shows the correct equation and value of x, the cost of each cavity filling.
So the cavity filling would be the unknown, right? The cost, or
which shows the correct equation and value of x, and the x would be that very last part of that sentence, the cost of each cavity filling. So I'm going to write that down. X, that means, I wrote a little arrow, x is cost of each filling. I'm just going to say filling.
that would be the same way as you put it last time, though, like the unknown, right? That's what
Correct. Correct. Yeah. So like in the equation, what they're solving for, what the unknown is, the cost of each cavity filling, the cost of each filling. All right, I'm going to read it one more time. The total cost of Anha's trip to the dentist was $628.35. So 628.35. That's the total. So a lot of the time, whenever they say the total amount of something, that's usually like there's a complicated equation or like an expression on one side, then it's equals, and then it equals the total, because the whole point of the equation is to like do some math on the number and then end up with a total. So on one side of the equal sign, usually, not all the time, but usually is the total. So when they say the total of this, or everything costed, or added all together, it equaled this thing.
The total.
Yeah, that's the hint that that number is going to be on one side of the equal sign, and then the algebra stuff will be on the other. So the total cost, that's a hint to me that we're going to say equals, so like something 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 equals 628.35. I'll go over this real quick after we switch screens, just to, because I'm writing it down. I'll just explain again. But the hint to me is 628.35. That's probably on the right side of the equation all by itself. And then she paid a flat fee of 89.95. So 89.95 flat fee. So she has to pay that anyway. And which included the checkup and cleaning, and then had 4 cavities, each of which cost the same amount. Okay. All right. Can we switch?
Yeah, for sure. If you need me to read it back to you, I will.
Okay. All right, so just reading that first part, uh, or the end of the sentence, we figured out that x is the cost of each filling. 628.35 is the total cost, so that's my hint that there's probably going to be an equation where there's something over here and it equals that amount. And then 89.95 is the flat fee. So the cost of each filling. Oh, how many fillings? That was another thing.
She had four
fillings,
right?
Yeah.
And they all cost 95, right?
So each one, we don't know the cost of each one. Actually, the cost of each filling is going to be X. Yeah, that's what we're going to figure out. But
all right, cool.
We have to pay $89.95 no matter what. So I'm going to guess that the right side is this, just all by itself, the 628.35. So I'll just write that way over here, 628.35. And no matter what, I'm going to have to pay this flat fee. It doesn't even matter how many cavities I have. It doesn't matter how many fillings I need.
Yeah.
So I'm going to say, all right, that one is probably all by itself, $89.95 plus, and then I know I have 4 fillings. So like we don't know the cost of each filling, right? But if each filling costed $2 and I needed 4 fillings, how much would I have to pay?
$8, right?
$8. You're just multiplying, yeah?
Mm-hmm.
So then I would take 4 because that's the number of fillings, and then times. Well, I said before, like if the cost was $2, then we just multiply. So then I'm just gonna put the x in there.
We just gotta figure out what it's gonna be.
So does one of the answers say that, or either like 4x?
All right, let's go.
Which one is it?
So one of them is 4x plus 89.95 equals the total amount. That's the top one. So x equals 134.60. So we can just do a little calculation, right, and see if you want to.
Right. So yeah, the way we wrote it, or the way I wrote it first, is the same as probably the way that it's showing up. So then now, like we got the equation part right, we just need to solve it. Do you want to try and solve it on your own, or you just want to follow along? Doesn't matter.
Yeah, I'm gonna do it right now.
Okay, I'm gonna do it on my calculator and see. We'll check.
Yeah, the top one, the first one's good because it comes out to just 4 times 134.60 will equal about 5 something, and then you add the 89.
Right. Okay. So did you plug it in?
Yeah, I just did it on like.
So you did. So this is just to see like how you solved it. So the first one, it said like x equals 134.60 or something like that, or just 6.
Are you writing it down? Yeah, the first one is 60.
Okay, so the way that you solved it, did you just plug it into there and go 4 times that and then add this?
Yeah, that's how I did it.
Perfect. Like that's how you should solve multiple choice if you have multiple choice. I'm going to show you the other way too, but that's right. That's what I got too. But to solve the equation without having choices, you do this. So the way you did it is completely correct. So if you have multiple choice, do it that way because that's the way that you'll probably remember. But I just want to show you another way so that maybe if there's a different situation, you have another option. So again, this is a 2-step equation. So you got to look at the number that's farthest away from the x, which would be 89.95. So you would do the opposite, subtract 89.95 from both sides of the equal sign. minus 89.95. Do that part in the calculator. You would get 4x equals, let's see, 628.35 minus 89.95. 538.4 or 40, and then divide by 4, because now it's just a one step. You do the opposite operation. This is 4 times x, so you do divide. So x equals divided by 4 should be the same thing. Yep, 134.6. And since it's after the decimal, you can add as many zeros as you want. So, cool. We could go on to the next one. I mean, you would have gotten that one, so I think we're good. I just wanted to show you a different way. All right, Vance 8. All right, so with the fractions, that's the thing. It's like a whole separate thing.
These are the ones that messed me up.
Yeah.
Because even if you get like to the end and then you're like at the, you do the same to the left side and then you go to the past the equal.
Right.
Let's say it's 440, and then you add the 4/5 to it. Most of the time you just do whatever the multiplication to the 4 to the 4 on top, right?
Yeah. So that's the thing. Yeah, it's like another layer.
Number?
Yeah. All right, so let's see. Vance ate a salad and 4/5 of a turkey burger for dinner. The salad contained 80 calories, and his entire meal contained 440 calories. Which equation can be used to determine x, which is the number of calories in the entire turkey burger? Okay. So x, I'm going to write that down. X is the number of calories in the entire turkey burger. So the salad contained 80 calories. So he ate a salad and then part of a turkey burger. And the salad contained 80 calories. So I'm going to write that down. 80 calories in salad. And his entire meal, so that's total calories. That's what I'm going to say. Total calories. And that was 440. Total calories. Okay, so that's a hint. The entire meal being the total, that was a hint. What do you think, like for the equation, what do you think will that mean with the 440?
That means that like 440 is going to be the whole next to the equal sign, right?
Perfect.
It's going to be a whole.
Yeah, it's going to be by itself. Side. Like there's going to be 440 and an equal sign and nothing else next to the 440. So it's either the first answer, probably, or the third one or the fourth one. So we can kind of like forget about that second one.
Second.
All right, so let's see. What was X, the number of calories in the entire turkey burger? All right. Do you have a guess, or like, do you want me to just go through it? Because this one's a tiny bit different.
Is it easy, you think? I think I'll try to figure it out.
I think it's just like still notation and translating words into like math. Here, let me just show you, because when I only said it once last time, so.
Those fractions always get to me. I don't know.
Yeah. Sometimes like the best thing to do. Well, shoot. Sometimes you can change a fraction into like a percent, and it might make it easier. But there's so four. It was 4/5, right?
Yeah.
4/5 of. So he ate 4/5 of the turkey
The
burger.
burger.
All right. So X is the calories, and just by looking at the answer, I saw that the 440, instead of on the right side, it was on the left side, but it was still all by itself. So that's what I'm gonna say. Like I'm gonna start out my equation with that, just because this part,
That's how it's written.
yeah, it hints at like 440 being all by itself. Then the next thing is he ate 4/5 of the turkey burger, and we're thinking that's actually the same thing as 4/5 of the calories from turkey burger, T burger. Does that make sense? Like he's eating 4/5 of the turkey burger, but he's also only getting 4/5 of the calories from the turkey burger because he didn't eat all of it.
Burger.
And the only reason I'm saying that is focusing on calories. The only reason I'm focusing on calories is because they're telling us that the whole equation is supposed to focus on calories. So really, I'm going to think about calories the whole time. And instead of the entire amount of calories for the turkey burger, he's getting only 4/5 of. Remember, translates to multiplication. So what I could write, and I can't remember the order that it was showing, but I could do 4/5, and then of is multiplication. So I'm going to do multiplied by, and then I'll look back. Well, 4/5 of the calories from the turkey burger, and the calories from the turkey burger, from the entire turkey burger, is X. So 4/5 of this unknown amount. If it was 4/5 of like 100, it would be, actually, if it was 4/5 of 5, then I would get 4 calories out of the 5 calories that was the entire burger. But we're doing 4/5 of means multiply, so of X. But then he also ate a salad by itself. Whoops. And the salad was just 80 calories on its own. And it might have these two things switched around. Is one of the equations that?
Yeah, there's one that's exactly how you wrote it.
Okay. The other way to have written it would have been like this bottom one. Those are the same.
Yeah,
it's just switching around the addition part. So yeah, those are the same thing. Does it ask you to figure out X?
Which equation can be used to determine X, the number of calories in the entire turkey burger?
Okay, so there's only one option that has this. Is that right?
The way you wrote it down?
Yeah.
Yeah.
Okay.
The first one.
And it doesn't have like a semicolon equals X?
No, that one doesn't.
So I think when it does have the semicolon and then X equals, that just means you have to solve for X2. And then now you have two ways to do that. You could either solve the equation, the two-step thing, doing the 2 steps, or you could just take that X and plug it in, whichever way you remember to do or whichever way you feel comfortable with.
Okay.
All right, let me stop and then you can go. What is the value of X in the equation 1/3 X? X is in the middle. Excuse me. Minus 2/3 equals -18. All right. I'm going to share mine, and I'm going to compare it. the hardest thing for this is the fractions, because if there were no fractions, I think you'd have no problem with it. It'd be super easy.
Yeah, I think it'd be pretty easy.
So let's just identify first the number that's farthest away, and then the number that's closest to the x. That's on the same side of the equal sign. So like I don't even care about this -18. I'm not going to do anything with it. But what's the number?
It'd be the 2/3, right?
2/3 is farthest away, and then that means the 1/3 is the closest. Yeah.
Yeah.
Okay, so we deal with the 2/3 first. Do you remember what you would have to do with the 2/3?
So that's just negative, right, next to it. So we're gonna multiply.
So you're doing the opposite operation. So what's the opposite of the minus?
Of that, yeah, would just be subtract. I mean, just add.
Yeah. So we'll add that to both sides.
So that doesn't mean it's a negative 2/3. It's just because it's just there.
It means we're taking away 2/3. It can mean just to like expose you to this, because sometimes they write it like this for no reason. You could actually do plus and then make it a -2/3.
Oh, okay. So then
And
we
that-
have to add that to it.
Yeah, so like in this case, both of these mean exactly the same thing. And that's just something that, like, once you do a lot of it, you'll get used to.
Okay.
So that means we're going to be doing the same exact step on both of these. I would add 2/3 here. I would add 2/3 there, and they would still cancel out. So like the opposite of either the sign, if there's only one, or the opposite, or sorry, opposite of the operation, if there's only one sign, or the opposite of the sign if there's two operations. And then, I mean, it still gets more and more complicated, but we'll see more and more notation as we get there. It's just
Yeah. So this is what I don't get. How like okay. So the 2/3 are gone, right?
right.
Zero
This
goes
cancels out. This cancels out.
Now how do you add
this part.
or subtract or what? Yeah.
Right. Okay. Yeah. Let's get to that.
That's what always messes me up, and I just get.
So, when you have a whole number and a fraction, you can't really do anything with it until they're both fractions with a common denominator. So here we would have -18, and then plus, I should do this in a different color. -18 plus 2/3. We're doing this part. So when you have a fraction and a whole number, you can't just work with it right away because you can't really compare them. Like there is, like if you had like a really skinny cup and you had a really, really wide cup and they're both filled with water, it's kind of hard to see which one has more water than the other one because the cups aren't the same. Like, do you know what I'm talking about?
Yeah.
That's the same thing here, like with the 3 on the bottom. It's hard to compare because this also doesn't have a 3 in the bottom. Like, think of it as like a cup. So really what I want is this to be a fraction with a 3 in the bottom. Then I can compare them, then I can manipulate them. So what I'm going to do is for the whole number, you put it over 1. And then for the fraction, you don't do anything. And then you find a common denominator. So in this case, and we'll probably get into it later when it becomes more complicated fractions, but in this case, the common denominator is going to be 3. And the only way I know that is because I can multiply this 1 by a whole number, 3, and it will become 3. So I would do that in the top and the bottom. And the only reason I'm allowed to do that is if I have 3/3, that's equal to 1 anyway. So this, 3/3, is the same thing as 1. And if I multiply anything by 1, I'm not really changing the number. Like that, well, I think we'll get into that a lot more, but the reason that you do it in the top and the bottom is because it doesn't actually change this -18. It just makes it look like it's in a different cup. So 18 or negative 18 times 3 would be negative 54. And then 1 times 3 would be 3. Now, if you take this and actually do the division in your calculator, 54 divided by 3, that's going to be 18, but it's a negative 54. So negative 54 divided by 3 is negative 18. So it's actually the same value, it's just in a different cup. That's how I think of it. But now, they both have 3's on the bottom. So after you get the same thing on the bottom, you can just write the bottom once, and then only pay attention to the top numbers. Negative 54 plus 2, that's like 54 negatives and 2 positives. The 2 positives cancel out with 2 of the negatives in the 54, so you get negative 52 over 3. And then you see, maybe you can divide it, 52 or negative 52 divided by 3, it's 17.333333, so maybe we'll just leave it as a fraction for now.
Oh, okay.
So this part ends up being negative 52 over 3. Do you have any questions yet? Because we still got one more step. That was one step. The thing that makes it hard is...
I kept getting stuck on that part. I didn't know you could just add the 1 underneath the solid number.
Yeah. For any whole number, you can always put it over 1.
Okay.
And that's the only number you can put it over. You can't just like put in a 2 there because that changes the value.
So the 1.
But 18, like negative 18 divided by 1, that's still the same thing as negative 18. If you put in any other number, negative 18 divided by 3 is negative 6. It changes the actual value. So the only number for a whole number that you're allowed to put it under is just 1. So that's how you make it into a fraction, and then you do this part to get it into the same cup, and then just combine the tops once they're in the same cup. Then we have 1/3 x equals negative 52 over 3. The last step, we did it once yesterday, so I don't expect you to remember, but when you have a fraction times the variable, one way you can do it in all in one step is you can multiply by the reciprocal, which just means you flip over that fraction. So I flip it over and multiply, and I do that to the same, or to the other side as well. I'm not flipping over this one because this one doesn't have the x.
Yeah.
I'm only flipping this one over and then doing that to both sides. So then I have a 3 on top, 3 on bottom, and a 1 on top and a 1 on bottom. That's the same thing as 1x or just x. So now x is all by itself. And then I have a 3 on top. And then, these don't cancel out, so you can write it like negative 52 over 1. But same thing where you can take a whole number and put a 1 underneath. If there's already only a 1 underneath, you can just write negative 52, yeah.
Okay.
So that's the one, like, that's 2-step equations plus dealing with a whole number, adding or subtracting a fraction. And so you get a common denominator with that. So that's probably something we'll run into more, so like we'll eventually review that more and more.
How much harder is this from algebra? I know we're not like even close, but algebra is way harder.
So I don't know. This is the beginning of algebra. So
like pre-algebra, right?
Like whenever you're using variables, that's algebra. So I don't know why they call it like pre-algebra. This is like the beginning of algebra 1 from when I taught it. So it does get into like quadratic equations where it's like x squared and like exponents and stuff. But I mean, it all builds, so when we get there, we'll be okay. So I mean, that's in a while, I think. But it shouldn't be something that we can't handle, I think.
All right. No, I mean, I trust it. I just wondering for myself.
Yeah. So like all the stuff that we're going to be doing, we're going to continue doing. It's just going to be like now there's an extra step, or you do it again and there's like something else that you have to switch, and then it becomes the same thing that we've been doing this whole time. And then once you like understand that, it'll be like, oh, something else is different, and you're kind of like translating it down to something that you've learned before. So really, the only new stuff is how do I make this problem look like a problem that I already worked with, and like we'll just keep going from there. But that's generally how they progress. All right, Karina spent a total of $5.27 buying a pineapple for $3.40 and some tomatoes that were on sale for 85 cents per pound. To determine the number of pounds of tomatoes she bought, X, Karina wrote and solved the equation as shown below. So 340, what was 340? 340, she spent a total.
It was the pineapples.
Yeah, buying a pineapple for $3.40. Okay, so she bought one pineapple for $3.40. Okay, so that $3.40 all by itself, that makes sense because she bought one pineapple. So the $3.40 should only be by itself. It shouldn't be multiplied by 2 or by whatever. And then 85 cents per pound. Well, we know that the number of pounds of tomatoes that she bought was X. So 85 cents times the number of pounds, 85 cents per pound times the number of pounds will give you the total cost of the tomatoes. And then we're adding on that $3.40 to get the entire cost, which they said was $5.25 or 27 cents. Okay, so that equation makes sense. What would be, just looking at that top equation, what would be the number that's farthest away from the X?
The 340.
The 340. So what would you have to do to the 340?
So we do 340 minus 340 right under that, and then minus 340 to the 5.
Perfect. So let's
27.
do that. 5.27 minus 3.40. All right. Something's different, right? Do you see that? What did you get?
Yeah, I got some messed up number. 334. Let me do it again in case I did something wrong. Minus 340. Okay. I got negative 3.4. I don't know unless you're calculating it wrong or something.
Okay, so here, let me share real quick after I write this down. 340 plus 0.85x.
I'm going to just be typing.
Is 5.27.
187.
There we go. Yeah. And they got something different, right?
Yeah.
So you did the 5.27 minus the 3.40, right?
Yep.
And that's how you get the 187? That's correct. They got something else. If you had to guess, what do you think they did instead of 5.27 minus 340?
She must have added the number closer to the X first. I don't know.
Maybe. You could do
try it out.
5.27.
She added. I think she added instead of subtract.
I think so. Yeah. Because you do 5.27, and if you didn't do the opposite, you do plus 3.40, and that gives you what she got. So she added when she should have subtracted. Which one is that one?
Karina did not make any errors. The initial equation that Karina wrote was incorrect. Karina should have subtracted. So it'll be the third one.
Yeah. All right, cool. Ooh. All right, this is a crazy one. Which equations have the same value of x as 2/3 parentheses 6x plus 12 equals negative 24. Select two options. Okay. Hmm. All right. There's a couple ways to do this, but some of them they haven't talked about yet, so maybe I won't do that. But here, let me.
This is the first time I've seen that line going all the way across, so it's the same as the putting the parentheses or whatever.
Yeah, yeah,
on both
okay.
sides.
All right. Yeah, there's a couple different ways to write this thing, and it means the same thing. So I kind of want to just mention that, but then also see how we can solve it as well. So I'm going to share my screen right now.
Sure. Okay.
All right. So there's a couple things that this is like the same exact thing. So like I could write it like this. Where the line extends not only underneath the 2, but it continues and extends under the 6x plus 12. That means the exact same thing as this.
Okay.
Also, actually, those are two ways to like think about it, kind of think about it simultaneously. Like those mean the same thing. Then, I think one thing that they do is, actually distributing. I don't know if you remember, but if you have a number outside of parentheses and there's like a plus or a minus, if there's like one thing and two things inside the parentheses, then you can distribute, which would be like multiplying to each thing.
On both, yeah.
So there's two ways to do it. I'm going to actually distribute. And then just write it in two more ways that are still they all mean the same thing. So let me copy this. So here I could distribute, which just means multiply. And when I say multiply, I'm not actually saying like multiply it out right now. I'm just saying like write down this number, 2/3, write that down next to this one. So 6x. And I'll put parentheses around it just to emphasize that it's multiplication. So that's the first distribution. The second one, I'm distributing to the other one. So I would write the plus and then this number, 2/3 in parentheses and a 12 in parentheses. And I'll keep the equal sign and the negative 24. So this actually means the same thing as that and that. But that's not one of the answers, right?
I'll check right now. No.
Okay. So we could do a little bit more to this, but that's kind of complicated. So I'm just going to leave that one. I'm going to see if we can do more with this. There's a lot of stuff going on this one. Here, if I distributed just in the top, like the way that I wrote it, I can distribute just the 2 to those things, which means I would have 2 and then 6x, that's multiply. I have the plus sign, and then 2 times the 12. But I didn't do anything with that bottom, the divide by 3, so that's all still there. And then equals negative 24. Is that one there? That's probably not there either, right?
Yeah. They got one that's 18x plus 36 with that big line and then the 2 on the bottom.
Okay. I think I'm kind of trying to do too much all at once. maybe we'll just try and solve this, and then we'll look at solving the other ones.
Okay.
All right, so I think this is actually a three-step equation. That's interesting. So 2/3, actually. This is a three-step equation. So here, if you had to like think about like with the parentheses and how that changes how far away a number is, what do you think is the farthest thing away on this side from the x? What do you think is the farthest away?
2/3.
The 2/3, yeah, because the parentheses groups the 6x and the 12 together. They're the closest to the x. So the thing that's farthest away is this 2/3. So we got to deal with the farthest away first. And since we have a fraction, like again, we had like a 2/3 before it was just an x equals, I'm going to say 8. The way to solve this, like the furthest thing away from the x is just the only thing that's near the x. You would multiply by the reciprocal, and you do that to both sides. Same thing here, except for instead of just x, we have the 6x plus 12. This is kind of behaving the same way that this x behaves. So we can do the exact same thing. To get rid of this, the thing that's farthest away, we do the exact same thing that we did here. So multiply by the reciprocal, 3/2, and you do that to both sides. So times 3/2. I like to put them in parentheses. This one doesn't have a bottom, so you can always put it over 1. The 3 cancels out with the 3, the 2 cancels out with the 2, and it leaves you on this side with 6x plus 12. I don't need the parentheses anymore because I don't have anything there, and I don't have any exponents, but that's like for later stuff. So I'm just going to leave off the parentheses. And then here, since I have two fractions and I'm multiplying, I just multiply straight across the top and straight across the bottom, and then see if I can divide later. That's one way to do it. The difference, I want to point this out because people get confused all the time. Here, I had to get a common denominator and like make it in the same cup. Here, I didn't have to, and the difference is that I'm multiplying. When you're multiplying, you just multiply straight across the top, straight across the bottom. When you're adding or subtracting a fraction, then you do have to put it in the same cup.
Okay.
So that's just something I want to point out. Negative 24 times 3 is
72.
Yeah, negative 72. So a negative times a positive is a negative, and then 1 times 2 is just 2. And then can we do negative 72 divided by 2? That's negative 72, 72 negative divided by 2, negative 36. So that was one step. We just simplified this in the same thing. 6x plus 12. All right, now we'll think of this as a completely new problem. What is the farthest thing away from the x on this side?
The 12.
And then what do you do with that then?
So you're going to subtract the 12 from the 12 and the 12 from the 36.
Perfect.
The negative 36.
So here we got 6x, which that cancels. So negative 36 minus 12, the way I think of this is like 36 negatives. There's 36 of them, and then there's 12 more negatives. So nothing cancels out here. They're all negative. So if they don't cancel out, then they just add together. So that's the same thing as just knowing I'm going to have a negative at the end, and then 36 plus 12 is 48. And I know that they're negative because they were all negative before, and I'm just combining them. Does that make sense so far?
Yeah.
And then what's the last thing you got to do?
you gotta get rid of that 6, or
Right, yeah. So we have 6 times x right now. So how do you do the opposite to the other side, to both sides, actually? What do you do?
you gotta do the same thing, right? We divide the 6
And then
over
divide
6, zeros it
6.
out, and then
Yep.
the same thing.
So that cancels, and we got x equals negative 48 divided by 6 is negative 8. So that was a 3-step problem. One was getting rid of this number by multiplying by the reciprocal to both sides. And then we took this and simplified it. Then the next step was getting rid of the 12 because that was the next farthest away. And then finally we got rid of the 6, which was the closest to the x. All right, now let's see if we can make it make sense with the other equations. Can you read me the 4 equations there? I'm going to write it in purple.
Yeah, the first one is 4x plus 8 equals minus or negative 24.
Okay.
The second one is 9x plus 18 equals negative 24. Third one is 4x equals negative 16. Fifth one is 18x plus 36, and it has that big line underneath the big line.
Okay.
The division line is number 2 equals negative 24. And the last one is 4x equals negative 32.
All right, does that look like how you were saying them?
Yeah, that's them.
Okay. So, since we solved this one and we got x equals 8, and it's saying which equations are the same, if you solve each one of these, sorry, x equals negative 8. I don't know if I said negative, but if we solve each one of these and we get negative 8, then that means it's the same. If we get something else, that means it's not the same.
Okay.
So we'd start solving each one first.
Okay.
Oh, and it says only choose 2, right?
Only 2, yeah.
Okay. Can you try and solve the first one and see what you get? And I'll do it too.
Yeah, so it should be negative 8 over the 8, and then and since that one's a negative 24, it's just going to become a negative number, right? So it should be negative 32.
Perfect. So you get something like 4x equals negative 32, right?
Yeah.
Okay, and then the next step?
Then we got to do so it's 4 times x, so then we do we do subtraction 4, division, right?
Yeah, division.
The 4 and 4, so that just zeroes it out and leaves the x, which would equal. Oh, and then I do the 4 to the 32. Never mind.
Yeah, you got to do it to both sides.
So it'd be 32 divided by 4. Equals 8. And negative 8, right?
Negative 8, yeah. Here's a thing for multiplication. I'm going to say for multiplication and do that like this. Multiplication and division. If you have, so this is the way we kind of remembered. How did I write it? Multiplication and division. If you have, so you can have like a positive times or divided by a negative, and you'll get a negative. It's like we used to think of it as like a pig winking at you. Like there's an eye, there's a wink, and there's his mouth.
Yeah.
If you have positive times a negative, you end up with a negative. If you
every
have
time.
a negative times a negative, you end up with a positive. Like no matter which combination, if you have a positive times a positive, it's just going to stay positive. And then the same thing goes for
Okay.
division. So like here we have a negative and a positive, and we're dividing, so that fits with this. So then we get a negative and a positive make up a negative. So our answer is going to be negative. So we get -8. So that one actually checks out, right?
Yeah.
All right, what about the next one?
What about the division and the multiplication? That one, does that turn into a negative also, or that just stays?
So this is for both, like those rules. If you pair up this one and this one, you end up with the third. If you pair up this one and this one, you end up with the third.
Okay.
If you
Okay with that. Oh,
the only thing you kind of have to remember is just but this is like normal. Positive times a positive, that's always going to be a positive. Does that make sense?
yeah, yeah.
Okay.
I've
That's
heard
just
this
a way
before.
to remember it.
I do the big face.
And it's like it's supposed to be multiplication and division, just to kind of remember. Addition and subtraction, there's different rules, but like we can get there if we need to. So for this equation, does that one check out or no?
Let me get to it right now.
Or write it down too.
4. So we're gonna do so the 18s go out. So I'll do -18 would be 10. Be -42.
Yeah.
And then we get to 9x. So I'm gonna multiply the 9 to 9 and 0. Or it's gonna 0. No, we're gonna divide it.
Divide it.
Yeah. Zero that out, and then I'm gonna divide the. I think it should be 7, right? -7, or is it?
Yeah. Well, I don't know. 42 divided
42 by 7. No, that's
42 negative divided by 9. Yeah, it's like 4.6 something, 66666 something 7. That's correct. That's definitely not this though, right? Or it should be negative because there's a negative.
Yeah, that's not the answer. So
right, so that one doesn't work out. What about the third one?
So this is a quick one, right?
Yeah, what do you guys do?
There's 16, so I'll do the 4 divided by 4, cross that out. 4 divided by 16. 16 divided by 4. Well, that one's wrong.
Right, it's a -4, so not that. This one we'll save to the end. This one's easier to try, right?
Yeah.
So let's try that last one.
So it'd be that the bottom one.
Yeah, because you divide by 4, same steps as the other one, right?
Yeah.
X equals -8, and it said to pick 2. So this one, I'm just gonna show you. I'm just gonna run it through real quick, and then we could just move on. What? How much time do we have left?
We just ran out, but it's fine though, because I can go back to it. And we can check the other ones, I believe.
Okay. Well, let me run through this one, and then we'll talk more. We didn't get to answer that one. Oh, was that number 7 or number 6?
I think it was number 7.
Okay. All right. Let me just run through this one. 18x plus 36. All of that divided by 2 equals -24. So before, I was telling you when there's this big long line underneath, I think it was, what was it? It was at the very beginning. Oh, it's here. Oh, maybe not.
Yeah, when you put the 2.
Yeah, well,
Well,
if
when
there's a
you have
big
the
long
2, right?
line,
You did the 3. Yeah.
it's the same thing as if there was parentheses around here. So if I put these parentheses around, because that's what this big line means anyway. Deal with the top part first, and then deal with the
Okay.
bottom part, like in the order of operations. But if I were to put the parentheses around, which number would be, or do you think, you had to take a guess, which number would be the farthest away on this side from the x?
Even with the 2 being down, it should be the 2, right? Even
Yeah,
though
the
it's down there.
2, because it's not
Right?
inside the parentheses. And whatever's in the parentheses is going to be closer to the x. So the 2 is the farthest away. And what are we doing with the 2? Are we adding the 2? Are we multiplying by the 2? Are we subtracting? Or are we dividing by the 2?
We're gonna multiply, right? Because that's the division line.
Right, yeah. So we're dividing, so the opposite would be multiplying. So put a 2. You could put a 2 over 1 if you wanted to, just to make them both, because this is a fraction and this is a fraction.
Oh, okay.
So you would multiply, because we're dividing by 2, so that means we got to multiply by 2. And then 2 over 1 is the same thing as 2. But you don't have to put the 2 over 1, so we can just multiply by 2 on this side as well.
So that one still zeroes itself out?
Yeah, that 2
okay.
and that 2, they cancel out. And it's because of this grouping symbol, this division, it's considered a grouping symbol. Like, for a long time, I used to always just put parentheses to remind myself anyway. Anytime there's a long division, whatever's on top, I just put in parentheses. Whatever's on bottom, too, I also put in parentheses. But it's a grouping symbol as well. So the 2's cancel out, and we just get 18x plus 36 equals, what is that, 48, negative 48. And then now this is like a regular 2-step problem, yeah?
Yeah.
What would the next step be?
So now we, let me write this down real fast. Oh, so now we're going to do the subtract the 36 from itself. So that one will zero itself out, and then we'll subtract 36. So it should be 70, let's see, 84, right? Negative 84.
Negative 84, yeah. And then the last step.
Then we're going to have the 18x times, and then we'll divide the 18 to 18, zeroes itself out, divide 18 or 84 by 18. So I got like 4.66.
Yeah, that's what I got too. So same as that other answer, but not the one that we wanted. Those ones take a long time, and I think the easiest way to do them is actually solve the original and then solve the rest. There's like fancy ways of doing them, but I think the easiest way to remember is just solve this and then start solving. And like the test tip would be solve the easier ones first, because like we did this one right away just because it was first and we got something that matched. This one was like really, really easy. We could see right away that it didn't match. And then this one was also really, really easy, and we saw that it did match and we were done. But the way that you handle this one is just by knowing that, okay, that means there are parentheses there, so the farthest thing away is that 2, so you do the opposite, and then just go from there. So it's actually not that bad, but still, for this type of problem, I think solving the original and then just solving the other ones and seeing which ones are the same.
So now it's trying to shoot me to the course. So it's not going to let me see that pretest.
What's the course? Like, wait, so the lesson, it gives you a lesson after the pretest?
Yeah.
And you said today you took an actual test?
Yeah, so I'll do the lesson. So like this one right now, I'll let you see my screen so you can see it.
Okay.
You can go through it.
Because you said you completed the actual test and then got another pretest. The pretest is what we just did, right?
So this is the one we just did, yeah. But since we didn't have enough time, can you see it?
Yeah.
Because we didn't have enough time, it gave me like a 50 or a 60. So now it's going to make me go to the course and just show me, and then it's going to give me the test again, which might have some of the same questions, but it'll throw some different ones in there.
Okay.
So like the last one, it had like 3 of the same questions that we did already.
And that you did that just earlier today?
Yeah.
Okay.
So like this guy will speak, and then like he'll kind of explain, how can you solve. Then they'll give me like he just explains like every step.
Right. Okay. Do you think we like the same thing that we did today? Hopefully, we'll get through something faster. But I don't know. Like, is this how you would want to keep going, or you want to try something different, or like what do you want to do?
Well, I mean, I think even just because for me watching these guys or ladies, whoever shows me on here, it's hard to get, because they don't really show you the way you're showing me, like on paper and how to solve it, and they're kind of just telling you, and giving you like certain words to know, like this, distributed property equation.
Right.
But they don't show you anything, and then they might give you a little example, and then you kind of have to go watch videos on YouTube.
So,
but the thing is, like these steps that you showed me today.
And what's the test? Is the test timed also? Is it like the similar thing to the pretest?
Yeah, I think some of them, like the last final one of this course. So let me back on. I'll show you. So like earlier today, I had an English course that I finished today, and I had to write like an essay or whatever. So I started. I don't know what it's.
This is your course.
But I'll show you.
Because I'm thinking maybe what we should do is like whatever way we just did that lesson, we do it. If we get through it, we get through it. If we don't, then you try to take it on your own like you did today.
Yeah.
And if you pass it, then we'll just move on. What happens if you don't pass the test the next time you try to take it? They just do it again, or
I get 2 tries. I think once the third one, the teacher, I have to contact her. She will unlock it for me. And if I fail that time, then it's like, hey, you're doing something wrong, or you're just,
Okay.
Then it's like we have to talk. We have to have a meeting or a get together, and I have to explain, like, show her notes and stuff.
So there's the pretest, and if you pass the pretest, you just skip the lesson. If we don't get through the pretest, huh?
Yeah. So if we would have passed, then it, like, even though yesterday we passed the one, it still made me do the course.
Oh, it did.
I got the same test, and then I did it. Yeah.
Okay. So the pretest.
But it was easier because.
Yeah, the pretest is good anyway.
Yeah.
Okay. I'm thinking maybe we should just try to keep doing the pretests together. And then if you want to try the tests on your own, if you feel comfortable, go for it. If you want to do the tests together, we can do that together too. But it's up to you. But I think
I'm going to do exactly what. So like tomorrow, I'm going to try to knock out the little course,
Mm-hmm.
If I get to the test, and then if I get into a problem where I can't solve and I'm like stuck, I would just save and exit.
Oh, and then we could work on it together.
Then we can work together, yeah. Just for that one question,
Mm-hmm.
And like that.
That sounds good.
But I think even, like I said, even just from me working with you and you showing me the steps, it's way better than the course itself.
Right. It's like had kids that try to go through something online on their own, and it's just not like when you're not talking to someone, it's just, and
Yeah, you're not
expect them to
focused. You know, you're
understand
just
like just a diagram. It's hard.
and then you got people can be on their phone or
Right.
so like you are listening to the video, but you're not really listening.
Mm-hmm. Uh,
But knowing these steps, I kind of get it now, so I can
all right. Well, I think on this one, I'm a call this session, but next time we'll just pick up wherever you are, because if you want to, or like if you can get through the next set of stuff just based on what we did, then perfect. And if not, we'll just work through that and then continue progressing. Does that sound good?
That sounds good. I'll stay on right now, and I'm gonna try to get to this course
Perfect. Even better.
and see how I do on the course, and then tomorrow or the next day,
All right.
next you and see if we get it together.
Yeah. So I'm gonna go right now, and then I'll upload the video, and I'll send you a link whenever it's done uploading.
Yeah, cool. Yeah, because this one was very, very, very knowledgeable.
All right. Cool.
Thanks
I'll
again, bro.
talk to you probably tomorrow if you can still do tomorrow. Actually, tomorrow it's Christine's birthday, so I'm probably not gonna be able to do it tomorrow.
Don't worry about it. Yeah, don't worry about it. That's why I said, like, if we can't do the math, I can always work on English, So
Okay.
I just want to
pick up.
So whenever you have a chance, I'll wait here.
All right. Cool. Well, then probably the next time would be Thursday.
For sure.
All right, and we'll just figure out the time later on.
All right, thanks, brother.
Yeah. Have a good night, man.
You too, man. Thank you, man.
Bye.